Earth Systems 3209. Unit 5, Earth's Resources. This unit can be referenced in the textbook in Chapters 21 and Appendix A and B. Unit 5, Topic 3.3. This topic will focus on components of petroleum traps. The focus will be on identifying source rock, caprock, and reservoir rock as the components required to form a petroleum trap, and also focus on relating porosity and permeability to the reservoir rock. When we look at the components involved in the formation of a petroleum trap, there are three main components involved in the formation of petroleum traps. These include the source rock, the reservoir rock, and the caprock. If we look at the diagram to the right, we can see a schematic that outlines all three different components. The source rock will be the rock in which the hydrocarbons initially came from. The reservoir rock will be a rock that's basically permeable to liquids, namely water, oil, and gas. And the water, oil, and gas, the liquids, can actually move through and be stored and trapped within the reservoir rock. The caprock is basically the seal that keeps all of the liquids within the trap. This is an impermeable rock layer that has no porosity or very little porosity and is basically impermeable. When we look at the liquids within an oil trap, the liquids within the reservoir rock separate by density. So density is the key to separating all three of the different materials that's included in petroleum traps. Water, oil, and gas are separated according to density. Within the reservoir rock, the higher density water will be located beneath the lower density oil, which is located beneath the lower density gas. So this is the layout that you would find in liquids within a petroleum trap. The water will be located beneath the oil, which is located beneath the gas. Let's first look at the source rock. Source rocks must contain an abundance of organic matter, and this organic matter will eventually form into kerogen, which eventually is released and migrate throughout rocks where it is stored as petroleum. The petroleum is often created and released from the source rock while lithification is occurring. That is, while the sediment is changing into sedimentary rock. Examples of source rocks are shale and limestone. The diagram to the bottom would show you an example of a source rock. Where sediments contain more than 5% organic matter, it eventually forms a rock known as black shale. And the black shale basically would be rich in organic matter. The second component involved in petroleum traps is called the reservoir rock. And this is the rock that's responsible for holding or encompassing the hydrocarbon deposits. A reservoir rock requires high porosity and high permeability, since it is the rock which petroleum moves through and is stored in. Note, at this point, we should look at the two definitions of porosity and permeability. Porosity is the volume of pore space or holes between the sediment grains within a rock. And permeability is the interconnection of the pore spaces, thereby allowing the movement of liquids, namely in this case petroleum, to move through the rock. And this property, permeability, directly determines the rate of flow at which liquids move through the rock. So porosity and permeability are two important factors that determine the ability of a rock to become a reservoir rock. When we look at reservoir rocks, porosity of the material depends on and is influenced by three factors. The porosity is directly dependent upon the particle shape, the the particle size, and the degree of sediment sorting. When we also look at reservoir rock, large, rounded, well-sorted particles offer higher porosity. Therefore, they particularly if the amount of cement between them is limited. Usually, the higher the porosity, the larger the pore spaces, and the higher the permeability. So if we look at reservoir rocks, particle shape, such as round versus angular, would provide a higher porosity. The size of the particles, if you have bigger particles relative to smaller particles, we generally have higher porosity. And if we have all particles the same size, they would have a higher porosity than if they were varying in size. So porosity is dependent upon the shape of the particles, the size of the particles, and the sorting of the particles. Also, examples of reservoir rocks include sandstone, dolomite, and conglomerate. These all have high porosity and high permeability. Note, petroleum exists within reservoir rocks contained between sediment as opposed to being confined to whole volume of liquid petroleum. Therefore, there are no ponds of petroleum in the ground. So if you look at the diagram to the right, we notice that petroleum is located between the sediments, and they are located in the pore space between the sediments. We do not see petroleum within the ground as a full volume or a pond of petroleum within sediment. As oil migrates, it fills up the pore spaces. Therefore, oil-filled pores are shown in the black areas in the diagram to the right. A third component of petroleum traps would be called the caprock. The caprock is an impermeable rock that serves to trap petroleum from either escaping to the surface or spreading throughout the rock. An example of a caprock would be shale. Shale is impermeable and has little to no porosity. Therefore, it keeps the oil confined to the reservoir rock. Let's look at some examples. Example number 1. First question reads, which rock type would have the high porosity and high permeability? So if we look at the rocks of choice here, A would be granite, B would be quartzite, C would be sandstone, and D would be shale. From previous studies in Unit 3, we noticed that granite and quartzite are igneous and metamorphic rocks, respectively. Therefore, they do not have porosity and permeability. Our choices then would be restricted to the sandstone and the shale. The sandstone is made up of larger particles and generally roundish in shape. Therefore, it would have the higher porosity and permeability. So the answer to this question will be sandstone, C. Second question reads, which is the highest porosity and highest permeability? So if we look at all the components of an oil trap, the caprock, reservoir rock, and source rock, and trap rock. Here we see that the caprock and the reservoir rock are the two main components within an oil trap. The one that has the highest porosity and highest permeability will be B, the reservoir rock. This would be the layer of rock that actually holds the oil, and it also allows the petroleum, namely oil, to migrate through the rock. Caprock is an impermeable rock layer, so therefore it would have no porosity or very little porosity, and would have no permeability. So the answer to this question would be B, reservoir rock. Example number 2. First question reads, which rock is most likely to be the target for an oil company? So when an oil company is looking for oil or exploring for oil, is looking for a rock that has a relatively higher porosity and higher permeability. And this would prove to be a good reservoir rock. So our answer to this question would be D, it would have to be a porous sandstone. Porous sandstones would have the space in between the sand grains in which oil would be found. Second question reads, which would be the best caprock in an oil trap? So caprocks would have to have the ability not to allow liquids to pass through. So they would have to have low porosity and low permeability. And those two properties will be seen in an impermeable shale. So the answer to this question will be C. The best caprock in an oil trap would be impermeable shale. Your turn. Take the time to complete the following question. You can pause your recording now to prepare your answer, and the solution will be on the following slide. The question reads, which characterizes the best reservoir rock? So a reservoir rock would be a rock which would have relatively high permeability and high porosity, which allows the liquids, namely oil, to pass through and be trapped within the layer. So the rock that characterizes the best reservoir rock would be A rock which has high permeability and high porosity. Examples of rocks that have high permeability and high porosity would be sandstones, dolomite, and conglomerates. So your answer to this question would be A. Let's look at a summary of the points covered in this presentation. There are three components of a petroleum trap, and they include the source rock, which is a rock that contains abundant organic matter, which is responsible for releasing the hydrocarbons. Such examples of source rocks include shales and limestone. The second component of an oil trap or petroleum trap is called a reservoir rock. Reservoir rocks have relatively high porosity and high permeability. An example of this type of reservoir rock would be sandstone. And finally, the caprock is the impermeable rock that traps the oil and holds it within the reservoir rock. So a good example of a caprock, which is an impermeable rock with low porosity or no porosity, is shale. So the three components of a petroleum trap would include the source rock, which is the source of the organic material, a reservoir rock, which would hold the hydrocarbons as they migrate through, and a caprock, which is responsible for trapping the petroleum within the reservoir rock.